Good afternoon, everyone. It's 12 o'clock, so we might kick off very shortly. Welcome to today's webinar on methane climate change metrics. Over the next hour, we're going to be looking at what the science says and why it matters to Australia's ag industry. I'd like to begin today's session by acknowledging the traditional owners of the lands on which we work. In my case, I'm dialing in from beautiful Wadawurrung country on the Bellarine Peninsula in regional Victoria. And I acknowledge that our speakers and those watching today are joining us from different regions right across the country. And so we pay our respects to all elders past and present. My name is Kitty Walker, and I have the great privilege of being Farmers for Climate Action's Strategy Director. Now, just some quick housekeeping from me before we dive in. We use webinar mode, so we won't be able to hear or see you, unfortunately. So please put comments in the chat and questions in the Q&A. In the event that we can't get to all of your questions today, what we will be doing is collating responses to unanswered questions, and we'll share them with you as soon as we can. Now, in a week where the federal government has announced a major consultation process into the path to net zero for the ag and land sector, we'd like to thank two of Australia's leading scientists, Professor Mark Howden and Professor Richard Eckard, for giving their time and expertise today on all things methane. For those who are new to Farmers for Climate Action, welcome. We are a movement of farmers, ag leaders and rural Australians working together to ensure Australia adopts strong emissions reduction policies. We represent more than 8,000 farmers across Australia, and our supporter base includes more than 45,000 Australians committed to deep emissions reductions across the economy this decade. Now, we have got an incredible variety of people who've registered for today's webinar. We've got farmers from all over the country. We have leading representatives from across the ag industry. We've got ag tech groups, staff from ag departments in all state and territory governments, the Federal Ag Department, the Climate Change Authority, universities from across the country, and the Federal Department of Climate Change and Energy. So welcome to you all. Thank you for joining us. Now, our first speaker today, Professor Mark Howden, is the Director of the Institute for Climate, Energy and Disaster Solutions at ANU. He's also an Honorary Professor of the University of Melbourne, a Vice Chair of the United Nations Intergovernmental Panel on Climate Change, or the IPCC as it's affectionately known. He's a Fellow of the Australian Academy of Technological Sciences and Engineering and the Chair of the ACT Climate Change Council. Mark has worked on climate variability, climate change, innovation and adoption issues for more than 30 years. He's been a major contributor to the IPCC since 1991. And if this wasn't enough, he shared the Nobel Peace Prize with other IPCC participants and Al Gore in 2007. So I'm going to pass over to Professor Mark Howden now for his presentation. Thank you, Mark.
Thanks very much, Kitty, and thanks to Farmers for Climate Action for the opportunity to talk here today. And so what I'll be covering is as part of this picture, obviously a very small part, given that it's a complex topic, but I'll be doing what I can in the time frame. And so, just checking, Kitty, that there's a full screen.
You're looking good, Mark.
Excellent. So what I'll be talking about today is complementary with what Richard's talking about in a minute, but I'm covering particularly the implications of what's happening with methane in terms of the atmosphere, how that relates to climate change, some of the metrics, and addressing some of the issues that seem to pop up, like lifetimes of methane, what happens if we just produce constant levels of methane, etc. And so just sort of bringing to bear some of the science on some of those questions which are often asked. So firstly, the first point is that if we look at methane in the atmosphere, it keeps on going up. In fact, it's going up at record levels at the moment, and it's at record concentrations. So pre-industrially, it's tripled since then, almost tripled since then. And so we've got a very rapid increase in methane. And methane by itself is actually a very significant greenhouse gas. It does not cool the climate. So if you hear people saying, oh yeah, that's sort of in some way that methane emissions cool the climate, that's just not the case. Every kilo of methane that's emitted makes the Earth warmer than it would otherwise be. It is definitively a greenhouse gas. And what happens to methane in terms of whether we go up or down in terms of methane levels really matters in terms of global climate change. So methane is the second biggest human-caused greenhouse gas, and it currently generates around about 1/3 of the radiative forcing of carbon dioxide and 3 times that of nitrous oxide. So it's a big greenhouse gas contributor. And historically, since the pre-industrial sort of timeframes, methane has increased temperatures by around about 0.5 degree. Now, given that we've gone up roughly 1.2, 1.25 degrees since pre-industrial times, you can see that methane is a really big player in terms of the changes that we've already seen. If we let things continue as they are, it will be a big player in the future changes of temperature as well. Now, when we look at the sort of dynamics of methane in the atmosphere and its interaction with land and oceans and various other sources and sinks, there's an increasingly good understanding of what's going on. So it's not complete, but it's actually more than good enough to make sensible decisions about sort of policies and preferences for emission reductions. So we've got a fairly good science base on which to work from. Now, when we sort of look at that science base and the impact of methane on warming, we see that methane has both direct and indirect effects. So a direct effect is where methane acts as directly as a greenhouse gas. So it intercepts outgoing long-wave radiation and then re-radiates that. And in the process of doing that, it keeps the Earth warmer than it would otherwise be. But it also has indirect effects by its impact on things like ozone and ozone concentrations, on water and carbon dioxide concentrations in the atmosphere, all of these being greenhouse gases. And it particularly does that through its interaction with what's called the hydroxyl radical or hydroxyl ion, which is the active sort of molecule in the atmosphere that destroys methane. But it also has implications for ozone and other factors. And how this plays out in terms of the direct and indirect influences does differ slightly by source. And I'll talk about this, so particularly between fossil fuel-based methane and biologically based methane. So when we look at methane, we need to put it in the context of carbon dioxide, because carbon dioxide is the prime driver of climate change. It's the single biggest greenhouse gas from humans, and they're quite different. So carbon dioxide is a very long-lived greenhouse gas, which is relatively a lot weaker in terms of its warming potential than methane. Methane is a shorter-lived greenhouse gas with a lot stronger direct impact on climate change, on radiative forcing. And so very different characteristics, almost diametrically opposed. And so to enable us to compare those, we need to understand how we can generate a metric to actually do that comparison. So that's where we have those discussions about different metrics and the use of metrics. Now, it's pretty clear that there is no single metric that does answers every question. It's more a question of what are the purposes that are needed for decision making, and what are the metrics which are appropriate for that decision making. And when we look at the Paris Agreement, which is the prime international instrument through which climate change commitments are made and delivered, that has explicitly adopted the GWP100 metric as a way of converting methane into carbon dioxide equivalents. And having a universally agreed metric is pretty fundamental to easing the wheels or greasing the wheels of decision making, that enables us to make the rapid progress in terms of emission reductions that we need to make if we're actually to limit the impacts of climate change. So arguing for longer and longer about metrics would actually just be put the brakes on that necessary action. And so it's important to actually decide on a metric and to then build that into the processes that we need to use to reduce our emissions. And that's what's been decided. That was part of the Paris rulebook. So if we're going to choose a metric, what should a metric do? So it acts like a currency converter, converting methane into carbon dioxide equivalents in terms of its warming. And it needs to be simple. So it can be calculated easily. It needs to be cheap, so you don't have lots and lots of complex data requirements or calculation requirements. It needs to be predictable so that it's very clear an increase in methane has an implication in terms of warming, and it needs to be very transparent. So it's very clear how decisions are made associated with those metrics. And the purpose that you want all of these things is when you're actually designing or investing in or operating or monitoring some sort of emission reduction market or instrument, or designing an option, say on farm or elsewhere, to reduce greenhouse gas emissions, and you want to know the full implications of that. You also want ideally a metric that assesses the marginal climate effect of an emission action. So by that I mean, if we emit this ton of methane, what will it do in terms of future warming? And so we need to have a forward-looking metric that allows us to do that. And it also needs to be operated in a way that enables tracking and correction of policy and management. So a single point of time calculation is quite useful for doing that, rather than something which depends on either forward emissions or backwards emissions. And so that can inform effective decision making. And lastly, the point I have here, it has to be consistent with the existing policy and management environment, and not generate inequities. And Richard will talk about those inequities in the next section. So when we look at all of those criteria, the metric that does meet most of those criteria most effectively is actually GWP, and the decision has been made to use a 100-year time frame. So that's the GWP100 metric. And what that is it simply compares the warming effect of methane in the atmosphere over a 100-year period compared with the warming effect of carbon dioxide over the same period. So it's a simple ratio of warming between those two different greenhouse gases. Now, when we deal with methane, we actually have methane which can come from fossil-based sources. So if you think fracking and release of methane from that, or similar processes. Or you can have biologically based methane, which is methane from livestock or from rice paddies or similar sources. Now, when you take a fossil-based methane, what you're doing is you're taking a carbon molecule attached to the hydrogens, and you're taking it from underground and you're putting it up into the atmosphere. Now, when it goes into the atmosphere, it has the immediate effects in terms of warming, but then it has a subsidiary effect, because when it breaks down into a carbon dioxide. So you have the initial warming period as a methane molecule, and then you have a long-term carbon dioxide warming period. Then, and when the calculations are done, taking into account all the various sources and sinks of methane, the GWP100 under the most recent IPCC report was 29.8. If you take a biologically based methane molecule, to actually form that methane molecule, you're effectively taking a carbon dioxide molecule from out of the atmosphere, putting it into a much more radiatively active form, which is methane compared with carbon dioxide. And then it goes into the atmosphere as methane, which has the warming effects. Then that breaks back down into carbon dioxide. And that carbon dioxide is essentially equivalent to the carbon dioxide that formed that methane molecule in the first place. So if you actually think about that, you've got a temporary reduction with biological methane. You've got a temporary reduction of CO2 as it goes from CO2 into methane into CO2. So it goes from low radiative forcing to high radiative forcing to low radiative forcing. And that contrasts with a fossil-based methane molecule, which goes from nothing to carbon dioxide to, nothing to methane to carbon dioxide. So it's a different scenario that you're dealing with. And consequently, the methane emissions, the GWP from a biologically based methane molecule is slightly lower than that of a fossil fuel molecule. So that biological source is already taken into account in the calculations of GWP100, because there's two different factors there depending on source. Now, a lot of people talk about the lifetime of methane and what happens if we keep on emitting the same amount of methane each year. Doesn't that make us greenhouse neutral? And the answer is no. So if you actually look at this graph, this comes from Andy Reisinger from New Zealand. And this shows what happens if you have to methane concentration in the atmosphere if you have a pulse of methane. So you shove a little bit of methane into the atmosphere, you get an immediate increase in concentration, and then you get a long-term decline in concentration. So roughly half of that methane will disappear in the first 11 years. So it's got a half-life of 11 years, so it gradually declines over time. So that's what would happen if you had a single pulse of methane in a single year. You have a temporary increase followed by a decline. But what actually happens then, if we're talking about constant additions of methane, you've got lots of these pulses which add on to each other. And so this graph from Andy shows what happens if you just have the same methane pulse coming in year after year after year. So you do get leveling out of methane in the atmosphere, the methane addition concentration, but it happens after about 40 to 50 years. So if you're sort of thinking, oh, we can, just level it out in 12 years, that's not the case. And that's because of the lifetime of methane and how that propagates. Now, if we actually look at what happens if we have the same pulse of methane into the atmosphere, but how it influences the warming of the Earth, which is a slightly different thing, we get a different curve. So yes, we get the initial peak and followed by a long decline, but it doesn't go back down to zero. And that's because we've got residual dynamics of carbon dioxide in the atmosphere, etc. And again, what happens if we add year after year after year of the same pulse in terms of temperature? We see it keep on going up, and it keeps on going up. So the idea that just leveling off our methane emissions somehow solves the climate change problem simply isn't true. If we level off our methane emissions, the concentration goes up for a long time, and the temperature goes up and up for an even longer period of time. So we need to be starting to recognize that that's the dynamics, that's the basic science. Those sort of graphs don't have a GWP anywhere in sight. They're just the basic chemistry of methane in the atmosphere. Now, what does that look like in terms of the methane and nitrous oxide reductions that are needed? If we look at the top right-hand panel of this from the IPCC report, Working Group 1 report, it shows for different emission reduction scenarios that are sort of aligned with different temperature goals, how much you'd have to reduce your methane to be consistent with that goal. And so if you actually look at that, the top right-hand panel, to have a low or very low emission trajectory that's consistent with 2 degrees or 1.5 degrees, that's what the Paris Agreement goals are, we have to reduce our emissions by about 60% going over the long period. So this is the sort of information that's informed the Global Methane Pledge, which is a rapid reduction in emissions, but we need to continue that reduction, push down in methane emissions if we're to meet the Paris Agreement goals. So really important to note, a 60% reduction is not a 100% reduction. So under these scenarios, you don't have to go net zero for methane. What you have to do, though, is significant reductions in methane. And And that's really an important difference, I think, because we don't have the technologies to go net zero in methane from agriculture, but we do have the technologies and management to make a significant reduction. And that's a very, very significant difference there. Now, the last slide is in terms of global action. And at the moment, there is a lot of focus on reductions in methane emissions in the policy domain. And that's because reductions in methane provide relatively quick wins from reductions. So you can start to achieve emission reduction goals quickly with methane reductions. It's necessary if we're to keep temperatures within 1.5. You can't achieve 1.5 degrees unless you have reductions in methane emissions. And there's also a very, very high social cost of carbon in relation to methane. So a paper that just came out last week looked at their base case, or their median estimate was around $4,000 a tonne of methane, with a significant range around that. So that's roughly speaking 6,000 Australian dollars a tonne is your social cost of methane. That's the cost when you emit a tonne of methane. That's the aggregated cost over the lifetime of that methane. We also see significant policy activity there in relation to the Global Methane Pledge. So there's now over 150 countries that have joined that pledge and said that they're going to reduce their methane emissions at least by 30% from 2020 levels by the year 2030. That's a pretty ambitious goal. And many countries have started to develop policies and practice and programs to drive emission reductions down in methane across sectors. So that's not just livestock, but also looking at the fugitive emissions from fracking and oil extraction, etc. And really important to note that none of that actually needs a GWP metric. This is simply saying, we're going to reduce our methane emissions by 30%. You don't need a GWP metric to measure a 30% reduction. All you need is a good inventory. So as Richard will talk about, there's implications of different metrics and inventories, and we need to be thinking about this. But also really particularly is that, just reinforcing, we don't want to get distracted by GWP metric arguments, because what we need is absolute reductions in methane if we're to achieve the Paris Agreement goals. Now, I'll just leave it there and hand it over to Richard.
Thank you, Mark. And so Mark's dealt a lot with the chemistry of methane, or the science of methane. I'm more dealing with the inequity and some of the considerations that are more policy-based in looking at the problem. So just a reminder, this comes from Miles Allen's presentation in Canberra recently. And just a reminder on the global warming potential 100 and global warming potential 20, so 20 years or 100 years. And Mark was saying the biological methane multiplier is 27 times methane emissions is GW100. That comes from the IPCC 6 assessment report. What Miles Allen presented was a simplified structure of the GWP star metric, which is one of the questions we have. And if you break it down to a really simple equation, it says we're going to take methane from this year times 128, recognizing that that's the actual warming of a molecule of methane on a daily basis, empirically determined, of course. But we also say the methane from 20 years ago is now gone, and so we deduct 120 times methane from 20 years ago. Now, the right and wrong I'm not debating here. I just want to keep that in your mind, that that's the structure of the basic calculation. What does that mean for us then? But also, as Mark said, there's many other, if you read the radiator forcing chapter in the IPCC assessment report, there are many other metrics. This is only one of many that exist. So to take it to the inequity issue, one of the biggest barriers that we found in international negotiations is this attitude that we have of, well, the developed world, the wealthy world, created the problem using cheap fossil fuels to get rich. Now we're saying the developing world, the lesser developed countries or the emerging economies, or you could say the poorer countries of the world, telling them they can't burn the same cheap fossil fuels to get rich like we do. That introduces huge inequity. And so it has been one of the big stumbling blocks in international negotiations. So how does that apply to the choice of metric? Well, one of the problems with GWP star is it assigns 0 zero warming to constant methane emissions. Mark dealt with this. What it means in practical terms, take a Californian confinement dairy with 20,000 cows producing 3,000 tons of methane per year. They're considered to be climate neutral. In other words, no warming on the atmosphere. Well, Mark just told us that that's not true. But if their numbers decline by 3% per decade or 6% over 20 years, the GWP star says they have no warming impact, zero. Well, that's not true, because there's 3,000 tons of methane coming out every year warming the atmosphere. But the big problem from an inequity point of view is it heavily penalized the developing world. So a dairy farmer in Kenya, for example, that wants to send their kids to school, so it takes on an extra dairy cow, goes from 1 to 2 cows, they then get penalized for 90 kilos of methane times 128 as the multiplier, because this is a new animal. There's nothing from 20 years ago to deduct off. So suddenly you've got a emerging farm, 1 extra cow being penalized by 128 times, and a Californian dairy farm spewing 3,000 tons of methane per year. And I'd ask you on Mark's presentation, which one is warming the atmosphere more? But the other problem with the metric is it assigns different values to the same amount of methane. Imagine if that was an old Californian dairy farm versus a new development of 20,000 cows. The new development would have 128 times their methane, whereas the old one has 0. And I think we just haven't thought this through carefully enough. And what it leads us to conclude is that GWP star only suits a mature livestock environment where animal numbers are stable, decreasing, like in that graph on the bottom right, which is what's happening with livestock in Australia. But it actively disadvantages emerging economies from achieving their own food security or generating wealth through livestock. I would just, as an anecdote, I'd say, well, the other problem is it means that all new natural gas exploration and fracking gets multiplied by 128. And imagine that powerful lobby group taking that on board. But let me take it somewhere else. We know that all the major multinational supply chain companies have set targets for greenhouse gas emission reduction. And roughly, if you look at it, they roughly say 30% less total emissions by 2030 is where we're starting, but we're all going net zero by 2050. That's the multinational supply chain, and Australia is 70% export focused down these supply chain companies. Now, why is that important? They've all used the Science-Based Targets initiatives to set those protocols, those targets. And the Science-Based Targets initiative is based on the Greenhouse Gas Protocol, which is aligned with the IPCC and the Paris Climate Agreement. So the problem we face is if we conveniently choose another metric, we will find that when we try to sell to our supply chain by 2030, they'll say your metric doesn't meet our standard, and they have options on the global stage to go elsewhere and buy where they do meet the standard. So we've got to be very careful in making sure that what we're doing aligns with what our supply chain wants. That's actually the most critical thing for the future of agriculture, is meeting those supply chain targets. Now, another issue that I see is if you go to the red meat strategy in Australia, the 2030 strategy, it has the wording double the value of Australian red meat sales by 2030. What's not in the highlight, but is in the subtext, is it implies another 10 million animals into a herd of 25 million. So we're going from 25 to 35 million is in the subtext. That's the only way you can actually achieve that. There's a value add as well that's implied, but it does require increased animal numbers. What that means in practice is that with GWP 100, Mark was showing us it's 27 times all the methane from all the animals. With GWP star, if we adopt that as a metric, it means all new 10 million animals added to the national herd now are multiplied by 128, because there's no animals from 20 years ago that match them to deduct. Which, if you work that through, it means instead of a global warming of 27 in Australia, we would have an average global warming potential of 44. So now, because we achieved the red meat target by increasing the national herd, and we know the sheep flock want to increase as well, we suddenly have all new animals times 128 and an average weighted emission factor, global warming factor of 44. And I'm not sure that we've actually thought that through, that that's actually what we get. So to end off, I'd say the world's moved. Mark ended with saying the same thing. Targets are now being set for absolute methane, no multipliers involved. And you've got examples of the New Zealand target, 47% less. That aligns with what Mark was saying about the 60% ultimate reduction target. The California legislation, which is looking at 40% less methane, and the Global Methane Pledge, 30% less methane. These are not multipliers, they're absolute methane. And so arguments about metrics is just moving deck chairs around on the Titanic. And it delays, it says we're comfortable, we're climate neutral, we don't have to invest in any more methane reduction. And it delays research in achieving the objective. Because in the end, regardless of metric, zero methane is zero methane. Whether it's GWP star, 100 or GTP or any of those metrics, zero is zero. So I'll hand it back to Mark now, I think.
Thanks, Richard. Just a quick single slide on sort of a path forward based on a letter that Richard and Nett Cowie and I wrote to NFF a week or two ago, is that our view is that we need to move past the argument on metrics and the things that Richard was just saying then as part of that story. We need to focus on reductions in absolute methane emissions, and we need it to reinforce the social license of the industry, because there are alternatives coming that don't have the same emission reduction sort of baggage that the traditional agriculture does. And I put down the bottom of the slide a paper just from last week, which is actually just coming out of Nature, which looks at how we can have food without agriculture. And so we do not, I don't think we can afford to be naive about this. We actually need to maintain the social license, and that can happen best through effective action. We need to be thinking about investment in cost-effective and safe technologies. We don't want additives which actually cause problems with animal health. We need to have clear adoption pathways for our emission reduction activities, and we need to be working hard on consumer acceptance so that there's actually a positive market signal for what we're doing. And really importantly, I think we need to not just look on farm, but right across the value chain to actually think about emission reduction options, and because it isn't just about what happens on farms. At a policy level, I think we should consider separate reporting of different greenhouse gases. This is the position of the IPCC, because that allows more sensible discussions about different options rather than bundling things in ways. But at the same time, we need to accept that there is a need for overall targets, such as a 43% reduction in greenhouse gases, because that's a way of aggregating the different activities across different sectors. And of course, we need to improve our greenhouse gas inventories because that's the whole basis on which we can compare emissions from different sectors. So for example, the livestock sector from the mining sector, it's only when we have effective greenhouse inventories that we can actually identify responsibility and hence have priorities for action in those different areas. And again, I'll just leave that there and happy to answer questions.
Okay, thank you so much, Mark and Richard. I'll let you both, if you can both keep your cameras on and mics on. What we're going to do is to dive into some questions now. Richard, I did just want to acknowledge I had a wonderful biographical precursor to your presentation to show your credentials, but if people would like to know more about your background, they can jump on our website. It's on the event page there. I just do want to flag that I can see so many questions coming through the Q&A, and we had a record number of pre-registered questions. So we will collate responses to those we can't answer today, and we'll share them with you as soon as we can. Now, the theme of this question, it has been repeated by many, many people. So I'll ask this one straight up. As a rough estimate, how do methane emissions from Australian livestock compare with methane seeps from coal seam gas? Are those emissions significant or not? I'd like to know comparisons because I hear cattle are being scapegoated so that we don't focus where we should. Who would like to take that one?
So if we look at our national greenhouse gas inventory, we've got livestock methane being greater than the methane from the fugitive emissions from, fracking and gas and coal mining and similar things. there have been various reports which suggest that those emissions from the mining industry are significantly underestimated, and I think there needs to be work done to actually be able to identify the degree of underestimation. That's the business of improved inventories, improved methodologies such as integration of satellite measurements into on-ground measurements. And so I think, yes, it's good to be able to compare that, but it still means that our livestock are significant sources of greenhouse gas emissions, and regardless of whether fracking is big or small, we still need to reduce those livestock emissions.
Rich, do you have anything you want to add to that?
No, that's correct. I think in the Global Methane Pledge, one of the big challenges is quantifying what actually comes from the fossil fuel industries more accurately, because when we were arguing with government about the uncertainty in livestock methane, they pointed to fracking and said, well, try, at least we have an idea how many animals we've got in the country. Try the coal seam industry. We probably underestimate that grossly.
So how far off are we from sorting that out and actually getting an accurate picture of fossil fuel emissions?
Oh, we've got very good information on fossil fuel emissions from carbon dioxide. So when we burn a litre of petrol or diesel, we know almost exactly how much carbon dioxide is produced. The issue here is what's called fugitive emissions from leakage from coal mines. So when you're digging a coal mine, there's pockets of gas trapped in the coal and that sort of thing. Also from fracking, you can get fracturing of rock and leaking of methane from pipelines and from urban distribution systems. You can get leakage in your suburban pipes and things like that. So there's lots and lots of potential leakage points, and it's finding ways to calculate those. Increasingly, there's options to integrate different sources, as I said, from satellite information and on-the-ground measurements and other sources to actually estimate that, and that will be progressing over the next decade.
All right, we'll move on to the next question. Can the speakers clarify the difference between carbon neutral and climate neutral? Everyone needs to understand the important differences between these two. That is a good question. Who wants to?
I'll let Mark tackle this one.
Oh, okay. I was going to leave it to you. They're actually quite ambiguous terms, and so they're not well defined. But the general sort of idea is with carbon neutral, you're sort of looking at emissions of carbon dioxide being offset equally by planting trees or something like that, and so that's a thing to do with just generally speaking carbon and carbon dioxide, but it can be used to integrate other gases through GWP. Climate neutral is where you're saying, okay, well, we've got an action that is net doesn't increase warming in the climate. And so if you're starting to think about that, the implications of methane emissions come into play quite strongly in, say, agriculture about being climate neutral. The problem is that it's not well defined, and so people can use a different definition to effectively act as a definition of convenience for their particular interests, and that's where it breaks down trust, and it actually slows down the processes of action rather than speeds them up.
Okay.
So I think just to add to that, and Mark presented some great graphs from Randy Reisinger there, and the assumption is that under, say, the GWP star metric, that if you have a decreasing animal number by about 3% per decade, you are climate neutral. But actually, that's not true. And so that's why the definition is there. You're no longer adding new warming, but actually applying that to say GWP star achieves that is actually not true. So I think that graph that Mark showed of the cumulative warming that still exists, even if you are stabilizing methane, would be needed to be used if you wanted to claim the climate neutral outcome.
Okay. Okay, I'm going to bundle a sort of a theme of questions here. What is the realistic methane mitigation potential for the ag sector by 2030? And really, from a solutions perspective, what are the solutions to the livestock methane emissions? Is there really anything other than a reduction of the national herd size that will make a real difference?
I could probably start here. Look, there are options emerging. If we go back even 20 years, we didn't know we could reduce methane by 50%. There are now technologies in the marketplace coming through like Bovier that can achieve it. Now, granted, the problem is administration in grazing systems. So if you think of the confinement industry, well, you know, as of tomorrow, dairy and the feedlot industry could feed Bovier and reduce methane by up to 50%. The real challenge for research comes out to the more extensive rangeland systems. You think of half the cattle in Northern Australia, we don't get to see them on an annual time step. We don't even know where half of them are. So we definitely need translation solutions from the technologies emerging to the extensive industries. And, you know, the reality might be that we achieve dramatic methane reductions from the more intensive systems and less impressive methane reduction from the extensive systems. But it's not like we don't have options. We know legumes, for example, forages, there are forages coming through the breeding program at the moment that can actually have these secondary compounds in them that can work in grazing systems. So in the next generation, we'll have breeding options that can achieve 10%. We'll have legume options that can achieve 10%. I think where we headed is they'll have to be complementary. There's no one silver bullet that'll ever come out. To think that there will be is you know, Bovier might work in a confinement system under very limited conditions, but it's certainly not going to work to the same effect in grazing. So it'll be a bunch of solutions, and some of them are actually best practice options for introducing legumes back into our pastoral systems. So I think there's a range of options emerging. Whether we get to absolute zero methane from the national herd, maybe not, but we need to at least demonstrate we've done the research we need to prove that that's intractable.
Just following on from that, there's another question just around grazing herds and metrics. So do reporting metrics for methane take into account the cyclical nature of a grazing system, and are improved grazing practices part of the whole package of tools required to reduce methane emissions in ag?
Yeah, look, I'll pick that one up. So that's what I actually explained in terms of methane from biological origins, in terms of that carbon cycle. So that's actually included in that slightly reduced GWP100 for biological methane as distinct from fossil fuel methane, because it's actually part of a carbon cycle. And so that's established within the IPCC metrics. I wrote about that in 1991. I mean, so you know, like we've been trawling over this for a long time, and so there's, you know, like there's plenty of thinking there that you can draw from, which, you know, clarifies the nature of greenhouse gas emissions from whole of systems and what you can do to reduce that. So I noticed one question was, you know, well, what happens about fires and what happens about decomposition, etc. I mean, so all of that's been worked through. You can find that in the, you know, various you know, papers and reports and things like that. The critical thing comes back to that the key human influence on this is through you know, livestock, or, you know, what other human influence, you know, fracking or driving our cars or whatever, and we're not so much focused on fluxes or you know, greenhouse gas emissions or sinks from natural processes. What we're interested in is the human influence on those greenhouse gas sinks and sources, even if it is in a semi-natural system. So it's actually trying to get to the human influence that our greenhouse gas inventories are focused on. And just to throw in one additional point in response to Richard's previous comment about you know, what's the future of emission reductions. is that there is a cost effectiveness element there too. And so to be widely adopted, either it has to be cost effective because your methane treatment increases your productivity or some other benefit in terms of your production systems, or you've actually got some alternative way of ensuring that public good, which is the reduction in greenhouse gas emissions, is supported by public activity. And so at the moment, if you've got a commercial product which you're using to feed your animals, but you're not getting a productivity gain, why would you do that? You're paying a cost, but without a benefit unless there's a market response. An alternative would actually be to ensure that this was provided on the basis of public good by governments, and the cost for provision of those anti-methanogens and actions are actually provided by the public for public good purposes.
I think there's a question that's come through very recently that is a good tie-on from that. It says, it looks like all the heavy lifting will need to be done by farmers. What do you suggest needs to be asked of government, given the current lease of the Australian government's Ag and Land Emissions Discussion Paper seeking input from our sector? Which is very pertinent because we will all be contributing to that.
I might have a first go at this. Look, we're talking about a problem that is 50 million years of evolution in the making. And then we come along and throw 3-year funding rounds of drip feed money at this 50 million year old problem. We're not dealing with a small problem here. We're dealing with a fairly big issue. Just an example, the methane vaccine program has been going for, 25 years, I think, Mark? Mm-hmm. And we might, in the next 5 years, get a prototype methane vaccine. Did they fail? No. It's just a damn hard process. You're fighting biology that is stable evolution over 50 million years. And so, the Rimmen will throw every adaptation at every strategy. I just don't think we've taken the research seriously enough and thrown 10-year funding rounds at a intractable problem. Because if you really want to solve this problem or get to a point where you can prove that we can't solve the problem, you've got to be serious about the investment.
And I think part of that is actually recognizing that it's a global problem, because a livestock farmer in Uruguay has the same problem as a livestock farmer in Victoria, sort of thing, in terms of methane emissions. And so it's about how do you actually establish global consortiums, global groupings to work on different components of the problem and to pool resources and learning. And just Richard was just today talking down in Victoria with some people from New Zealand to relife one of those programs. So we need to be working at this at a global scale and recognizing that this is not just an Australian problem and act accordingly.
So on that front, with the Australian government signing up to the Global Methane Pledge, we've just hit the 1-year anniversary of the government doing that. Do we need a national methane plan, or what are as we're creating a net zero sector plan, do we need a specific plan for methane?
I think most definitely. There's no question. And some of us are putting together just such a plan at the moment. So we'll see in the next short while how that goes. But as following Mark's point, the New Zealand government has put $250 million into this problem already. The EU has put, something like 84 million euro into the problem in the last decade. We're not alone. And I think we've got to be careful about stamp collecting. What I call stamp collecting is they found it over there, so we're going to do it over here and waste our money. Whereas, if we look at the uniqueness of Australia, it's one of the few countries that has a big, extensive grazing industry. And so the solutions we've got to look at are not confinement feeding solutions. We've got to look at grazing system solutions to get somewhere. And so I think we've got to be more strategic about, if it's confinement animals, the Northern Hemisphere pretty much all over it already. Whereas if it's grazing systems, we're unique to some environments. So yes, a national plan, but really has to deal with the more extensive nature of a lot of Australian agriculture.
Well, in terms of not reinventing the wheel as well, you're talking about other countries who have, are investing significant funding and are further down the path than we might be in Australia, noting, of course, the unique situation that we are in. Are there things we can learn, things that successes that are happening that we can replicate and not start from scratch?
Right.
Oh, look, we're already doing that, and so there has been a history of working across some of these international bounds, and you know, Richard and others have been involved in this. ACR, the Australian Centre for International Agricultural Research, was sort of coordinating this for some years, and so there's, you know, there are precursors to this. I think it's just you know, exactly that, a precursor, rather than being you know, the final shape of what we can do internationally. But just one example of where we are benefiting from activities overseas is that product that Richard mentioned, Bovea, which is also called 3-NOP, and so that's you know, work which and a product which now we can import into Australia and use, which you know, significantly changes methane emissions particularly for intensively kept animals. And so there's, you know, a good example of how international work can propagate to generate benefit.
Is that commercially viable for farmers now? Or are we needing significant federal government support to make that viable?
Yeah, there's still some challenges there. There's no productivity gain to be made out of it, and so it is a net cost to farmers. And some recent calculations we've done, it would say, you know, a high-producing dairy cow is going to cost you 50 cents a day, and the pain point of methane reduction at $35 a tonne carbon price is about 7 cents per cow per day. So there's this difference of, you know, an order of magnitude that still has to be, you know, is that a public good? It might well be. Certainly, we've got some plans in front of government to do something similar with nitrous oxide from fertilizer, where we pre-farm aggregate the public good component of reducing emissions. It's a bit more different with livestock because, you know, you can't pre-farm aggregate livestock, but you can with fertilizer through the industry. So thinking through those challenges in agriculture, how do we make that difference? You know, other products like seaweed are now an order of magnitude more expensive per animal per day. The pain point doesn't change from that 7 cents per cow per day. So that's the target we've got to get under.
All right. There is a really good question here that I'm going to end on, and I'd love you both to answer this. And like I said, we will go through all the questions we've missed and all the questions that were pre-lodged that we didn't get to. Given there are a lot of farmers on this call and a lot of farmers will be watching this webinar recording afterwards, what advice would you give livestock producers should be the first action that they could take right now?
Mark, I could probably start and leave you to wrap up. Look, it's pretty clear the only way the supply chain can buy from you as a livestock producer is on a unitary value, not the absolute methane. Otherwise, they'd only buy small farms because small farms produce less emissions total than big farms. So they have to buy on emissions intensity, emissions per kilogram of live weight sold. That's what we're already seeing with Coles carbon neutral meat and with the various targets being set. What does that tell us? It tells us, how do you shift the dial on emissions intensity as your first course of action, waiting for the big technologies like 3-NOP to come through? And it's just through adoption of best practice. The biggest drop in emissions intensity you will get on your farm, which will put you at the front of the queue when JBS comes buying or when Graham's comes buying or Coles comes buying, is weaning rates, improving weaning rates, improving fertilizer use, improving the nutrition of the animals. And so it kind of re-empowers farmers to say, if you want to shift the dial, you can adopt best practice for the most efficient livestock system today. That puts you at the front of the queue when Coles comes buying for carbon neutral meat, for example. Well, because if they buy a bigger number, a higher emissions intensity, it costs them more carbon credits to get to their neutral target. So there's incentive for the supply chain to buy the most efficient product in the market. That's good news because it means we can shift the dial now. But how do we get to zero? Well, that's still very much in the research domain. Dropping that absolute emission down to zero is something that, is a challenge for the extensive industry still. Mark?
Yeah, thanks, Richard and Kitty. I was actually going to say efficiencies and best practice as well, because that's it's not only going to yield sort of easy wins, but it's also very consistent with the directions of change already within the industry. So it's all those little ways of improving things, not just on farm but off farm as well. So the thing I'd focus on then is as an alternative first action, given Richard's covered efficiencies, is basically push the question up the chain. So push it up into the farmer groups, push it up into government, and saying, hey, look, there's an opportunity for us to meet consumer expectations, to open up new markets, to have higher value product, to maintain social license, but we can't do it with the tools that we have. We need new tools and new options, and we want you to support the research and development, the long-term research and development that's going to give us those options, which actually put us in a really good position for the future.
Sure. Yeah.
Great final words. I'm going to wrap up now. Thank you so much to all of our speakers. Mark, Richard, your time is invaluable, and I really appreciate you making the time today. To everyone here attending, for everyone who submitted questions, and just for showing interest in such an important issue. Look out for the follow-up email with the recording, so you can go back and go over some of those key stats that might have been a bit hard to digest as we were going through. There will be a very short survey that you can fill out, and that will give you a chance to give us some feedback and let us know of any questions that you might have. Thank you again for coming along, and we hope you enjoy the rest of your day. Thank you.